Focus of this worksheet is going to be on solving linear inequalities. So when we were dealing with linear equations, we would have something of the form ax plus b equals c. We would know the left-hand side equaled the right-hand side, and our job was to find the values for x that made this true. Now what's happening is with a linear inequality in one variable, we're of the form ax plus b is less than or equal to c. With that said, the symbol between the ax plus b and the c can be a less than symbol, a greater than symbol, less than or equal, or greater than or equal. So now the left does not equal the right. It's either less than, greater than, less than or equal, greater than or equal to the right. And our job is to find the values of x that maintain that inequality. Okay? We just need to know that a, b, and c are real numbers. They can be integers, whole numbers, decimals, fractions, anything. Okay? Solving an inequality is the process of finding the set of numbers that will make the inequality true. This is very similar to the idea of an equation. We're looking for the value for the variable that makes the equation true. Here, because we have an inequality symbol, we're no longer dealing with one solution. We're going to have infinitely many solutions. So our job is to find the set of those numbers that make this value true. So it doesn't mean everything works. It just means an interval of values are going to work, and there's going to be infinitely many values in that interval. All right, the set of all solutions is called the solution set. That's fairly obvious. And these are the values that satisfy the inequality. Okay, these are the values that make the inequality true. Okay, so for topic one, the first thing we need to talk about is the graphs of inequalities. Okay, because we are dealing with a set of solutions, it's no longer just a single value, it's a whole interval of numbers. We need to know how to represent that visually. Okay, so since there are infinitely many solutions to linear inequalities, the solution set can be represented with a graph on a number line, and that is very frequently how we will represent our solution. Okay, a couple of things you need to know if you're dealing with inequalities. I like lost my train of thought there. If you're dealing with inequalities, again, you're dealing with an entire interval of solutions, and we have to find a way to represent this. And you also have to remember we have inequalities that are just less than or greater than, and then we have inequalities that are less than or equal and greater than or equal to a value. We have to find a way to show the reader that those two things differ, okay? So we have these endpoints. So let's say that we had x is less than 4, like what you see right here. We have to be able to determine, do we include the 4 or do we not include the 4? Okay, if we have x is greater than or equal to -2, do we include the -2 or not? Okay, so that's kind of what we're talking about when we talk about endpoints. That number that's part of the solution is the endpoint, and is it included or is it not included? So we have two different ways that we can represent the endpoint on a number line. We either use brackets or we use like little circles, okay? So square brackets are used to indicate that endpoints are included. You could also use closed circles, and I will show you both. All right. Round brackets, or just parentheses, are used to indicate that endpoints are not included in the solution set. As far as circles go, we would use what we call open circles. And like I said, I will show you both. So we're going to look at three different inequalities, okay? So example one, it says graph the solution to each inequality. When we graph on a number line, we just indicate some point on a number line. But now, because we're dealing with a whole inequality or a whole interval of solutions, we have to graph a point on the number line. We either use a square bracket or a round bracket, or a closed circle or an open circle at that point, and then we have to shade one half of the number line, or at least some portion of the number line. So let's look at part A. We have x is less than 4. That means values that satisfy the inequality are going to be values for x that are less than 4. They cannot equal 4. They have to be strictly less than 4. Okay? So what we would want to do is we would want to put either a rounded bracket or a square bracket at 4, and then we would shade everything less than that. Okay? Now, because we have x is strictly less than 4, that means we cannot include 4 in the answer. So 4 is not included. So I would put a round bracket on the 4, and then I would shade to the left. And this right here, this shaded region represents all of the values that are part of the solution set. 3.5 would work, -10 would work, 0 would work, 1 would work, 2.117894 would work. Exactly 4 would not work. Okay, that's why we put the rounded bracket there. 4 is the endpoint. We can go all the way up to 4 without actually including it. Now, if you wanted to, we could do the exact same thing. But at 4, instead of putting a rounded bracket, you would put a big open circle, and then you would still shade to the left. The open circle versus the brackets, it really comes down to the book you're in. They mean the same thing. I will accept both of them. Just know that the rounded bracket goes with the open circle. Okay? It kind of tells us there's like a little hole at 4. All right. Next up, part B, we have x is greater than or equal to -2. So our endpoint here is -2, and we have that x is greater than -2 or equal to it. So in this case, -2 is included. So at -2, I want to use a square bracket. You have to be very clear with whether you have a rounded bracket or a square bracket here. There can't be any like, ooh, is it round, is it not? You have to be very clear it's rounded or it's square. And in this case, because x is greater than -2 or equal, we're going to shade to the right. This tells us that values for the inequality, or values that make the inequality true, would be -2 or anything bigger than that. Now, as far as the circles go, we would locate -2. We would put a big circle there, but this time we want to color it in. This is what we call a closed circle. We've colored it in. We're saying we're plotting that point -2. There's not a hole there this time. And then we want to shade everything to the right. All right. Now, there's a third type of inequality. So you've seen the less than version, you've seen the greater than version, you've seen the strict, and then you've seen the or equals to. Now we have to do what's called a compound inequality. So when you're dealing with a compound inequality, you have 2 endpoints, and you either shade the tails or you shade in between. So in this case, we're going to be shading in between. So we're told that -4 is less than or equal to x, but x is less than 1. So we have this like interval of solutions that are going to satisfy this inequality. So we need to locate 2 endpoints, -4 and +1. Now, -4 has an or equals to inequality. That means 4 is included. So 4 is included, but 1 is not. Okay, so for 4, I'm going to put a square bracket. For 1, I'm going to put a rounded bracket. And then this says x has to be basically greater than or equal to -4, but it has to be less than 1. So our solution is everything in between these values. Now, as far as the circles go, we would locate -4 and 1. I would put a closed circle at 4 that tells the reader you can include the 4. I would put an open circle at 1, which tells the reader you can go all the way up to 1, but you can't include exactly 1. And then everything in the middle satisfies that inequality. So make sure you understand the strict inequalities. That's just plain less than, plain greater than. Make sure you understand the or equals to inequality. So less than or equal, greater than or equal. Make sure you understand square brackets versus round brackets, closed circles versus open circles, shading to the right, shading to the left, or these compound inequalities where you shade an interval kind of in between. All right.